everyone, I'm Asha Bhavani, working as an assistant professor in Marri Laxman Reddy Institute of Technology and Management in CSM department. Today my topic is Introduction to Java Programming Language. So the main concepts which I'm going to discuss in this session is Introduction to Programming Language, History of Java, Features of Java, and differences between procedure-oriented language and object-oriented programming language. So these are the topics which I'm going to discuss in this session. So first question is, what is the use of a programming language? So as a user, if you want to communicate with the computer devices, we need to communicate with a language. We need a language to communicate with the computer devices. So here we have several types of languages. By using those languages, we can interact with the computer system. Let's say, for example, we have C programming language, C++ programming language, Java, Python, .NET, like that several programming languages we have. By using these languages, we can interact with the computer system, right? So here, the programming language which we are going to learn in this session is Java programming language. So why we use Java programming language? Here, by using Java programming language, we can develop different kinds of applications. So what are those different kinds of applications that we can develop by using Java programming language are web application. We can develop web applications. We can develop web applications, desktop applications, mobile application. So like this, different kinds of applications we can develop by using Java programming language. And here, who invented this Java programming language? So the person who has invented Java programming language is James Gosling. James Gosling is the person invented the Java programming language. So next we will see the history of Java. So as I said that James Gosling is the main person who played vital role in inventing Java programming language. So along with James Gosling, there are other two main persons involved to invent this programming language. Those two persons are Mike Sheridan, Patrick Norton. So James Gosling, Mike Sheridan, Patrick Norton, these three people initiated the Java language in 1991. Actually, this programming language invented in 1991. The main purpose of inventing this programming language is to interact with the smart devices, to interact with some smart devices or to work with some embedded systems like electronic appliances like set-top box, remote, right, televisions. To work on these electronic devices, they may to develop the code, they use this Java programming language. So firstly, they used to call this Java programming language as a green talk. First name given to this Java programming language is green talk, and its file extension is .gt. Later, they have renamed Green Talk to Oak. So they have changed the name of Green Talk to Oak. So later they have given the name of the Java programming language as Oak. Why they have chosen this name Oak? Oak is the name of a national tree. It's a name of a national tree of some well-developed countries like USA, France, Germany, Romania. All these countries' national tree name is Oak. So they have chosen this oak tree name Oak as a name for the Java programming language. But though they have invented in 1991, the full version of Java programming has introduced in 1995. And they have also changed the name Oak to Java. Later they have changed the name of this programming language to Java. Why they have chosen this name Java for this programming language? So there is a story behind this. That story is when they're developing this Java programming language, the James Gosling and his team members used to consume lot of tea. They used to consume a lot of tea. So because of consuming consuming of the tea, so they got better ideas to develop this powerful language. And these coffee beans are produced in an island called Java. Actually, the Java name Java is the name of a island. It is the name of a island. In this island, they used to produce. They are producing effective coffee beans. The most effective coffee beans are produced in Java Island, right? So, due to that reason, James Gosling and his team members has chosen this island named Java as their programming language name. So that is how they have chosen the Java as the name of this programming language. So next, initially it was developed under Sun Microsystem. Java programming language was developed under Sun Microsystem, and complete version has released in 1995. But a significant milestone occurred in November 13, 2006. That is, a large portion of JVM has released in the market, and that software is free, and software is free for everyone. We can download and install that software, and we can work on that Java programming language. A free and open source software has released by the Sun Microsystem in the year 2006, right? As I said that earlier, it was under the Sun Microsystem, but later it was acquired by the Oracle Corporation. Now still the Java programming languages is developed under the Oracle Corporation, right? Next, we'll see the differences between procedure-oriented programming language and object-oriented programming language. See here, as I said that Java is a object-oriented programming language working on real-world entities. So here we have several types of languages like C, C++, Java, Python. So C programming language is a procedure-oriented programming language, right? So here, what is the difference between C programming language and Java programming language? Or we can also say it as the differences between procedure-oriented language and object-oriented programming language. So in case of procedural-oriented programming language, here the program is divided into small parts of functions. In case of procedure-oriented programming, the program is divided into small parts of functions. Whereas in case of object-oriented programming, the program is divided into a small parts of object. Next, in case of procedural-oriented programming language, it would be a top-down approach. So the program execution will start from top to bottom in case of procedure-oriented programming language. When it comes to the object-oriented programming language, here the program execution will start from bottom-up approach, right? So next, in case of procedure-oriented programming language, there is no access specifiers. Access specifiers concept is not present in case of procedure-oriented programming language. But when you see this in object-oriented programming language, we have a access specifier concept. So what are the access specifiers? Private, public, protected, default, all these are access specifiers. So by using these access specifiers, we can provide security to the program. So unauthorized persons cannot access our data if you use this access modifier from one class to another class. If you are giving permission, then only we can access the methods and variables of one class to another class. If I don't want to share my variables and methods of my class to the other class, then I'll make my variables and methods as private. So So I can make my variables and methods in my class as a private variables or private methods. Or else if I want, I can give access, only to the subclass. So in that case, I'll keep my variables and methods as a protected. So I will declare variables and methods as a protected variables or protected methods, so that I can give accessibility to its subclass. But outside of the package, no one can access the variables and methods which are declared with protected. Or else I can give access to all the people to access my data from my class. Then I'll make the variables and methods as public. So in this way, we can provide security to the data members inside the class with the help of access specifiers. So that is one of the best feature we have in object-oriented programming language. But this feature is not available in procedure-oriented programming language. So next, if you see here, in case of procedure-oriented programming, there is no overloading concept. Overloading concept is not available in case of procedure-oriented programming language. But when it comes to the object-oriented programming language, overloading concept is available. Like function overloading, operator overloading, method overloading concepts are available in case of object-oriented programming language. So with this overloading concept, what we can do is we can reuse the code. So next, here when it comes to the procedure-oriented programming language, there is no concept of data hiding and inheritance. But in case of object-oriented programming language, we have a concept called data hiding and inheritance. With these concepts, we can provide security, we can keep access authorization, and we can also reuse the code of one class to another class with the help of inheritance concept. So this is one more strong feature which is present inside the object-oriented programming language. Next, as I said earlier, with this inheritance concept, we can reuse the code. So reusability is absent in case of procedure-oriented programming language, but there we have a code reusability option is there in case of object-oriented programming language. So the example for procedure-oriented programming language is C, Fortran, Pascal, Basic. All these are the examples for procedure-oriented programming language. But whereas it comes to the object-oriented programming language, so the examples for object-oriented programming language are C++, Java, Python, C#. All these are the comes under the object-oriented programming language. So as I said earlier, procedure-oriented programming language is a top-down approach, whereas object-oriented programming language is a bottom-up approach. I said this point earlier. So we'll see with an example how we can say that whereas POP is a top-down approach, OOPS is a bottom-up approach is when we write C programming, we'll start the code with the help of from the main method. So we'll write main method first, int main, later int main. Here we'll declare some variables and methods, some local variables. We'll declare some variables, some int I. Later we'll write some functions. Inside of this we'll write some functions. So we'll write some functions inside the main methods. Function F1, F2, like this, different functions depending on the requirement we'll write inside the main method. So in this, the program execution will start from the main method. Later, it will enter inside the main method. It will execute the variables and functions what we have written in a sequential manner inside the main method in case of C language. This is how it would be, right? But so the program execution will start from the starting of the line inside the code. That's why we can say it as POP is a top-down approach. But when it comes to the C programming language, when it comes to the object-oriented programming language, so first we'll start writing the program with class. We won't write main method initially. First we'll write the class. So what is class? What is object? What is the syntax of a class? That we can see in the next sessions. But so in case of object-oriented programming language like Java, so we'll write the program with the help of a class. In the beginning, we'll write the class name. Let's say that my class name is A. My class name is A. Inside my class, I'll declare some variables. We can declare the variables, some int I. Later, we can write some methods. After that, here there is a method signature for main method. The method signature for the main method inside the class is public static void main. So public static void main, string args. Have a string args. So inside of this method, we'll create object for this class A. We'll create the object. With this object only, we can access the variables and methods of this class. Let's say that here I have a function f1. So a dot f1, right? So this is how the basic structure of a Java program. First, we'll write the class. Inside the class, we'll declare the variables. After that, functions. Thereafter, we'll write the main method, right? So in case of Java programming language, the execution will start from the main method. The JVM will recognize, the JVM will enter into the program through the main method, right? So the execution will start from the main method. Inside the main method, it will check the object creation. For which class the object is created? I have created the object for the class A. Yes. So it will create an object, and the memory for this object will be loaded inside the heap memory. After that, it will read the statement inside the main method. So a dot f1. So if we are invoking the f1 method with the help of a object A. So again, the cursor will move to the function f1. So if you observe this kind of flow of execution, here the execution will start from the main method. That is, so we can say that the approach for object-oriented programming language is from bottom-up approach, right? So with this example, we can see that so how the control flow is there in case of procedure-oriented programming language as well as in object-oriented programming language. So the next topic is features of Java. So we have several features of Java, like Java is simple, platform independent, and it is robust, portable, secure, distributed, multi-threading, dynamic. Like this, several features of Java we have. So few of those features we'll discuss now. First one is Java is simple. Why we say that Java is a simple language? Because the syntax of Java programming language is similar to the C and C++, right? So James Gosling and his team has developed the code for the Java programming by taking the help of C and C++ syntax. So that's why it is easy, it is simple and easy to learn. Next, here we have next feature is Java is a object-oriented programming language. So everything in Java is depending on the object. An object is a physical entity. An object is a physical entity or a real world entity also, we can say that. This object is having, in this object, this object is having two things. One is data, the another one is members. Data is nothing but, like, we'll declare variables. Members are nothing but functions. So this object will combine both data and functions together as a single unit inside the class, right? So that's why we can say that this Java programming language is a object-oriented programming language, and it also it is also follows OOPS concepts like inheritance, polymorphism, in abstraction. All these concepts will be applicable inside this Java programming language. Next feature of Java is platform independent. So why we can say that Java is a platform independent is, so once we compile the Java program, a bytecode is generated by the compiler. For example, I have written a program called a.java. A.java is my program name, my source code. This is my source code. And for this source code, I have given the name of this Java program as A, and I save this program with .java extension. Once I compile this program, the compiler will generate a bytecode. The compiler will generate the bytecode. It will generate a bytecode. A bytecode will be generated by the compiler. So this bytecode we can also call it as .class file. Class code or .class file is generated by the compiler. So whatever the code is present inside this .class file, that code we can call it as bytecode. And this bytecode will be given to the JVM. This bytecode will be given to the JVM. So the JVM will execute the bytecode of that Java program, right? And so this JVM, the architecture of this JVM is different from one operating system to another operating system. So let's say that Windows operating system, we have different types of operating system, Mac operating system, Solaris operating system, and Unix operating system. We have different types of operating system. So for every operating system, the architecture of JVM is different, right? If I want to run my Java program in my Mac operating system, so in that case, I need not to develop the Java program again. So I just take the bytecode and execute the program directly without writing the program again, right? So once we generate the bytecode, that bytecode can be executed in any one of the platform, in any one of the operating system. So that's why we can say that Java Java is a platform independent. Write once and run anywhere. Write once and run anywhere. Once we write the code and compiled, and the compiler will generate the bytecode, that bytecode we can execute in any one of the operating system, right? So this is one of the main feature of Java, right? So next feature is architecture neutral. So Java program never communicates with the platform directly, and it changes and upgrades in operating system, processor or system configuration will not affect the Java source code. Just now in platform independent, I said the same thing here we have. So once we generate the bytecode, that bytecode we directly execute in different operating system, right? We need not to change the code of the Java program, right? So that's the reason why we can say that Java is a architecture neutral. Portable. So portable also, we can carry that Java bytecode to any platform. For example, in my office, I have Windows operating system. I developed one Java application, right? And after I went to home, again, I want to work on my Java application. But at my home, in my system, I have Mac operating system. Then what I can do is I just upload the bytecode and I'll run the code directly. I'll execute the code directly. I need not to write the Java program again to execute that program in Mac operating system. So that's why we can say that Java is portable. Next, Java is secure. So why Java is secure? Because there is no explicit pointers, and inside the Java virtual machine, we have a JIT compiler. JIT compiler, it provides a security to our bytecode. So we are running bytecode in different operating system, right? So in different operating systems and different systems we will run. So it will, before it send that bytecode to the JVM, it will check the code of the dart class file, whether it comes from the authorized person or not. If it is not authorized, it won't send that bytecode to the JVM, right? So this kind of security is present inside the JVM. So that's why we can say that Java is secure. Next, robust. Java is robust. Robust means a strong language. It's a strongly typed language, and it will check the compile time errors at the compile time itself. And it has a strong memory management. Strong memory management in the sense, for example, while we are developing any real-time applications, the line of the code or the length of the code might be 10,000 lines, let's say that 10,000 lines. In this, some variables, after some times, some variables are left unused. Some variables are left unused. So these unused variables will be deleted automatically by the JVM with the help of garbage collector. There is a concept called garbage collector concept. With this garbage collector, we can deallocate the memory of unused variables. So that's why it provides a strong memory management. Next, we have exception handling mechanism. One more mechanism we have in Java, that is exception handling. With this exception handling mechanism, so we can overcome the abnormal termination of the program during its execution. Next, so these are the several features to say that Java is a robust language. Next, distributed. So the Java application we can run over the network, right? With the help of remote method invocation and EJBs, we can run this Java applications over the internet, right? So that's the reason why we can say it as Java is a distributed. Next, multi-threading. So one more important feature of Java is a multi-threaded. A thread is a lightweight process or a separate program, which a single program can be executed by multiple threads. With this, we can reduce the time taken by the program to execute. So here, in case of multi-threading, we can say that if a program is 5,000 lines of code is present inside the program, in this first 2K lines of program is not depending on the next 3K lines of code. First 2K lines of code is independent on the next 3K lines of code, right? If we are not having multi-threading concept, what we will do is line by line, all 5,000 lines of code should be executed. It will take more time to execute that single program. So to avoid this, they have introduced a multi-threading concept. In this multi-threading concept, what they have done is, so they will check the program and they will group the independent code of lines as a single thread. So first 2K lines of code is not depending on the second 3K lines of code. So first 2K lines of code will be assigned to thread 1. Next 3K lines of code will be assigned to thread 2. So these thread 1 and thread 2 both will execute concurrently. Thread 1 2K lines of code, whereas 5K lines of code both will execute parallelly. Initially, without multi-threading, line by line, the code has to be executed. Let's say that it will take some 10 hours of time. To execute a single Java application, it has taken 10 hours of time. So buffering time increases. Then people doesn't like to use that kind of application if it is taking more time for loading. But if you are by applying with the multi-threading concept, the independent lines of code we are grouping and making them as a threads. We are assigning to the threads. Every thread will execute parallelly. So here in this case, it may take only some 2 hours of time. Instead of taking 10 hours, we can execute the program in 2 hours. So this was the advantage of using a multi-threading concept. Yes. Next, we'll discuss about JDK, JRE and JVM. So here JDK is a software. JDK is a software. It's a toolkit. JDK full form is Java Development Toolkit. Java Development Toolkit. So inside this JDK, we have JRE and some development tools, right? So inside this JRE, again we have JVM. JRE means Java Runtime Environment. JRE is nothing but Java Runtime Environment. Java Runtime Environment. Java Runtime Environment. Next, JVM. The full form of JVM is Java Virtual Machine. Java Virtual Machine. Right? So first, inside the JDK, JDK is the biggest tool. Inside the JDK, we have JRE. We have JRE as well as development tools. Inside this JRE, we have JVM and library set. Right? So here JDK, by using JDK, we can develop the Java program. We can write the code for Java programs. But by using JRE, we cannot develop the program, we just run the program. Just by using only JRE, we cannot write the Java program. We just run the Java-based applications just with the help of JRE. And mostly JVM is used for executing the Java programs. JVM is used for executing the Java programs. So to execute the Java programs, whatever the libraries, predefined libraries are required, it would be taken from the JRE itself. Later, along with the JRE, we also have some development tools like to compile the Java program. So whatever the necessary packages and files are needed, which will be available in case of development tools. So once again, JDK is a software tool and JDK is used to develop Java program, and JRE is nothing but Java Runtime Environment. With this, we cannot write the code for Java program, but we can run the program just by using JRE. JVM is used to execute the Java program. So this was the structure of basic structure of a JDK, JRE and JVM. Next, if you see the in detailed picture of this JVM is, inside the JVM we have class loader, JVM memory and some executive engines. So first, once we create the Java program and generated the bytecode for this Java program, so this bytecode will be loaded by the class loader, and this class loader will send this. For example, my program is a.java. For this a.java, after compilation, it generated a.class file. This a.class file will be given to the JVM for the execution. So inside this JVM memory, we have method area, heap area, stacks area, PC registers, native methods. Later we have execution engine, native method interface and native libraries. So what is the use of each and every module inside this JVM memory? Basically, method area is used to store memory for variables and methods. So inside the class we have variables and methods, right? So the memory for these variables and methods will be allocated inside of this method area. Next, inside this heap area, whenever we create the object, inside the main method we'll create the object. So at the time of creation of an object, a memory is allocated for the object inside the heap memory area. If any extra memory is needed to store more variables and methods, they will be stored inside the stack area. And here PC registers. Inside of this PC registers, So inside the program, we have a set of instructions, right? So for every instruction, the memory is allocated inside the PC registers, right? So here, if you observe here, method area, which is used to store variables and methods. Next, heap area, objects are created and memory is allocated inside the heap area. Next here, in case of stack area, if more memory requires, then stack used to store variables and methods. PC registers, it stores the address of the method instructions to be executed. It will store the address of the next instruction inside the PC registers. Native methods, functions related to the C and C++ will be executed in native executed methods. Execution engine. So inside this execution engine only we have JIT compiler. This JIT compiler will check the bytecode before it has given to the JVM for the execution. With this only we can provide security to our .class files, Java .class files, when we are running these Java bytecodes in different operating systems, right? Next, so whenever JVM loads a class, method area and heap area are created, right? So this is about architecture of a JVM. Thank you.